Hi folks, welcome to another Wednesday widget. We're starting the Muzzle Brake series. We're going to manufacture a 9mm muzzle brake or compensator for an AR-15 rifle. This is why I love Tormach. This is a fun project for me. If you had asked me 2 years ago or 5 years ago if I could make one of these, I never would have had the confidence to say yes, and it excites me so much to think that we can do this. And here's the crazy thing, it's not even going to be that hard, I hope. So what we're going to do is we're going to break this down into 3 different segments. This is going to be the video on the CAD. Part 2 will be the video on the cam, and then in part 3 we'll machine it. We're going to use the 4th axis. We're obviously going to be using the Tormach PCNC 1100, and super excited. If I can say so myself, I'm not a terrible shot, but what we're going to try to do is a before and after and see how much better it performs and how the gun feels. And most importantly, it's a fun project. We're going to be thread milling and doing some more complex type stuff, but I am super excited. So let's dive right into the Solidworks and take it from there. I forgot to mention, and I have to bend your ear for 30 seconds, thank you folks. The response to the Christmas gift video has been incredible. I've received hundreds of emails with folks looking to enlist in the contest. But what's great is it wasn't just addresses. So many folks took the time to say thank you, and I appreciate that. But also the stories of, we get so excited on Wednesday for the Wednesday widget, or my son or daughter watches your videos religiously, or we watch them at work, or this has changed my child's thoughts on what they want to do with their life. That's crazy to me. I mean, that almost makes me think, it's mind-blowing, and it really makes me think this is incredible. My wife gives me a hard time sometimes about my internet friends, but folks, you guys are anything but that. You guys are more than friends. You're sort of my extended family. Again, feeling this relationship and seeing this how impactful these videos have been, that's all you need in life. It's incredible. So I want to say thank you, and I really appreciate that, and I wish everyone out there a very wonderful Thanksgiving tomorrow and a very Merry Christmas as we're coming up on the holiday season. Here is the CAD file, and we'll take a look around. Obviously, the end here we will thread mill on the Tormach to mate. It's 573 by 28. It's a little bit of an odd thread. I'll explain that later. And there's the muzzle brake compensating side of it, and then these in the front here are, I think, supposed to act like flash hiders. For those of you that recognize it, yeah, it's absolutely heavily influenced off of some existing designs out there. I just thought it would be fun to make. I can't find one in 9mm. Poked around, and there may be others out there, but let's DIY this and see if we can't have a little fun in the meantime. I'm using my space mouse to navigate through. It's actually been really helpful. I'm still getting used to it. I thought it might happen a little bit quicker, but it is great, and I think I'm going to love it, which means I don't have the conviction yet that I definitely will love it. So how are you going to learn how I did this? Here's what I thought. Rather than walk through these steps, let's create this thing again right now from scratch. Now, the dimensions aren't all going to be perfect because anybody can dimension things. That's not too hard. And we'll see. I'm going to trip up myself, and so when I do, we'll refer back to the existing model. But let's just see how far we can get, and hopefully it's a good way to learn. And as you guys know, I like to move pretty quick, but I'm always around in the comments below if and when you guys have questions. So new file, sketch. We're going to sketch the overall tube first, and we'll dimension that to 0.875. And then we'll extrude that out, I think about 2 inches. And then go the other way. Now, just so we're starting on the right page, let's make sure we're following the same size. So radius of 438 is good, and our length 2.25. Let's fix that real quick. 2.25. And actually, we need a clearance hole through there, which will be, we'll call it, yeah, it's actually fine. Again, not as focused on the dimensions precisely. Now, we'll add those flats on the back, and the way I'll do that is we're going to sketch, and if you see, we're going to create a plane right along the top. So we're going to insert reference geometry. Oops, I can't do it in the sketch. insert reference geometry plane, and we'll choose the top plane, and then we will choose the tube. Oops. Oh, there we go. Sorry, I had the wrong one selected. So now we've got a plane that's tangential to the top there, and all we're gonna do is choose that plane and sketch a flat. Oops. You know, like so. Dimension it however you like, and we'll extrude cut down to 0.125. See what that looks like. A little bit too much. Perfect. And then we will mirror that over the top plane like so. Okay, now let's deal with those tines, or the flash hiding tines at the end. What I did was we'll sketch on that face, and let's now take a look, not so much for being tripped up, but for trying to remember what the style was. Okay, so they're a little bit off angled, so let's try this. So we're just going to sketch, and we'll go here, and then we'll offset that by 0.25, I think is what I wanted to do. We may need to go look at this one. Oops. Okay. Now, it's going to bother me if I don't hide this plane first. And then, now I think this is going to be wrong, but we'll see. So let's sketch those down to something like 0.75. And what we did is then circular pattern. Actually, now is as good a time as any. We need to insert an axis through the bore. So insert reference geometry axis, and all we need to do is select these two, and now we've got an axis. So circular pattern, rotate about that axis. Features to be is this one. See what happens. Oh no, actually that is what I did. So the only other thing I added was a fillet, and we'll do, you know, 0.123 or something, not quite a full. And now let's drag that fillet above the circular pattern, and let's add it to, oops, perfect. Okay, now for the middle section here, how I did this, and I'm not a CAD expert, but rather someone who just gets it done, and this works so far. We'll use that plane that's tangential on the top, like so, and we're going to choose this straight slot tool and dimension it. I'll go 270, that will let us use a 1/4 inch end mill, no problem. And we'll put it out here, you know, 0.5. Oops, I wanted to do that. There we go. Actually, that dimension doesn't matter too much. 0.2. And the most important one actually is this angle of 30 degrees. And we'll extrude cut that through all. And we've got the slot like so, but if we take a look at the model I've come up with, as a layman, my understanding is how this works as a muzzle brake or compensator is you got more real estate on the bottom half than on the top, so you're deflecting gas upward to help push the muzzle back down. So we've got these little ridges here where the bottom again has more than the top. So what we do is we'll sketch again on that same plane, same slot tool, and what we'll do, dimension it the same width, and then if we choose these, hold on, so Actually, that's not going to work. So what I think I had to do is first you set the angle, but then you delete the angle and you can set that to 0. Perfect. So now we've got these two mated, and so what we can do is just, you can either drag it or set it numerically, however you prefer, something like so, and extrude cut. You know, we'll go down 5/8 and take a look at that. I think that's perfect. Okay, now to complete that, all we do is a linear pattern. Linear direction will be that axis along the bore. We'll do 2 of them. And hold on, feature pattern, let's get this selected here. And then we can take a look at it. Yeah, it looks pretty good. We'll do that, and then we will mirror them over the front. Yeah. Features to mirror. Boom, boom. Like so. That should have done it. Yep. We got the 4 grooves there, like so. Pretty crazy, folks. I mean, really, we've done very little to create a relatively complex, at least I think, model. Finish off the middle section. Same plane. Just going to sketch a box like so. Extrude cut. We'll go down, I don't remember if we want to go down shallower or not. We'll try 550. Okay, that's too far. I think we only want it down center line because it's 7/8, so we want to go down halfway. Okay, but then obviously I got to fix my box because I need it to cut through the bore. Perfect. I think my model, the width is actually a little bit thicker. Yeah, to tear thicker, but you guys get the idea. Not hard to tweak that as you see fit. So what else do we need to do in the CAD? I think just the dimples and then the logo, right? Yeah, because that was the mirror. So the logo I did have as a DXF file, so that part I can't replicate, but I can show you what you do is you copy it, which I just did here. Go into this model. We're going to go back to that same plane that we've been using, sketch plane 1, paste, and drag it around. Okay. Actually, this is good. So I was going to say that there's more space in my other model, which makes these this is too big. But actually, why don't we take this opportunity to figure out how to scale this? So that's easy. Under the entity here, there's a scale entities. Oops. And scale about. We'll just pick the center of it, and we're going to scale it down to 0.9. See what happens. I didn't have nothing happen there. Scale entities. Oops. Okay, got everything selected. Pick a corner. Oh, there we go. I don't know why it didn't happen the first time. Now, should still be able to. Oops, gotta select everything. You can tell my SolidWorks skills are sometimes a little bit off. Now we can drag it around like so, and then we'll do. Let's see here. Actually, I've got to cheat and go look. I know it's the wrap feature, but I don't remember where it is. Well, I think they actually have helpful. Well, fine. I'll exit the sketch then, SolidWorks, if you want me to. Oh, that's nice. Yep, that's one way to do it. Okay, we're gonna, I think, deboss, and we can. Oops. Yeah. Keep wanting to. That working? Oh, sorry. Face 1, sketch 16. Point. Well, that's too deep. Fix that. 15 thou. Actually, that's deeper than I'm going to do in the model, but you get the idea. No, here, actually, we will fix it. Go to 5 thou. And it creates that nice 3D contour of the logo. Pretty snazzy. Now, the dimples, I will admit, they took me a minute to figure out. Here's how we do them. We're going to create a sketch, and we're going to choose the front plane. So we're modeling on this plane. See, the logo's right here. That's the top of the brake. So this plane. Now, what we do is we choose a circle. And I don't want it to snap. And we'll smart dimension to that, say whatever we want, and then that will make point. You can do you can do the math behind this to calculate the depth. I'm just going to show you how you get the geometry to work. Okay, so that's what we want. We're just cutting in a little bit there, and we'll do a little bit more, 0.09. Now what we do is we do a revolve cut, and the axis of revolution is that. Oops. Oop, now I may have lied. Okay, I had a cheat. Sorry. I was hoping I could do that. Revolve cut. Oh, that's what I did. Hold on. Right, of course. Sorry, that's obvious. All you got to do is split this guy and then trim the top half. Now, we can do revolve cut, and that's the revolution, and boom, there's one of my dimples. Now, pretty easy to rotate that around the part. Just choose any of the radius edges, and I think I did 18, equal spacing, feature pattern, like so. Actually, there's no way I did 18. That's too dense. Let's go cheat and look how many I did. Huh, well, I'll be damned. I did 18. Okay, what did take me also a minute to figure out, though, is how do we create the next row? Something's not right. Hold on one second. Well, that is embarrassing, of course, folks. It's the fact that this is a 150 thou circle, and the half line is 63 thou above the top of the part. So let's go fix mine. That's, well, it is what it is. Embarrassing. So, oops. There it is. Way too big, folks, to make it look the same, at least. Okay. There we go. Okay, now, it took me a little while to figure out, I need to offset the next row half a click, half a notch over, so that the next row, they're centered on halfway in between. So what I did, again, it took me a minute to figure out, insert reference geometry, plane, and we know what I would intuitively think is, okay, well, we want to choose the front plane and we want to rotate it forward, I think it's 9 degrees. That kept giving me this odd angle, and what I realized is in the second reference, if I choose the axis we created, I've now there, I actually want to flip it forward, and actually I don't think it really matters. And that worked. Now all we've got to do is recreate that same sketch on our new plane. It's a little weird because you can't work on that square to that plane, at least that I know of. So we do a circle, and I don't want it to snap again. 0.15, and we're gonna, and then we choose the height, 0.063, just like so. Split it again. Boom, boom, trim. Revolve cut. around that. Boom, boom, and then do our circular pattern. Pick any of the radiuses, and that's great. And then all you have to do is go back and edit this sketch to choose the distance between the two, whatever you want. Oops. You can reference it off, you know, basically anything that you can find. And you get the second row. And then all I do is a linear pattern. I had to do a separate linear pattern for each one so that I could run it all the way to the end. So the direction will be the bore, and the items, features will be this. And let's flip it the other way, and that's way too far, 0.2. And again, you can work out the math so that these are all evenly spaced. So what the reason is that you can't, well, I'll show you. We've got one row that's off the geometry. I think we're going to get an error. We do. So back it down to 3, 1, 2, 3. That'll work. Whoops. I need to pick not the cut revolve, but rather the circular pattern. And then you just do the same thing for the second row. And features, oops. Features to pattern will be that. And we'll go yeah, it looks like that'll barely squeeze on. Perfect. That is, ooh, how did we lose? I forgot to mirror one thing. Forgot to mirror that guy. So we'll drag that above the mirror. That way we can go into the mirror and select that. There we go. Pretty cool, folks. Yes, again, I am not the world's SolidWorks expert, but I am pretty darn happy that we can create a model for that I trust, and it works right. You know, there's enough framework to this model that we can adjust it and have it be accurate and so forth. So that's a wrap for the CAD model of this project. Stay tuned. Very, very soon, we're going to go through all the SprutCAM 9 toolpaths and cutting. We are going to use the 4th axis. We don't have to use the 4th, but it's going to make it a lot easier. And then in the 3rd video, we will cut this part on the Tormach PCNC mill. Take care, folks. Thanks.